never had single person had so much power at their fingertips. Something like you literally have more power in your laptop now than the spaceships that flew to the moon. We're living in both a very scary time, but also a very exciting time. And I think like everyone has an opportunity to do something that was never possible before. The basic principles, the foundation of software engineering, computer science, algorithms, data structures, it will put you leaps ahead of people who just do vibe coding. There's nothing that really stops kids from doing this because a lot of programming is simpler than playing chess or some other things that 10-year-olds can do. AI will replace teachers. One developer just does a lot more and has more responsibilities because they can literally prompt their way to building an entire application. They tell like cursor, build this, build that, and then it just starts writing thousands of lines of code. I was able to do the analysis in 5 minutes that would normally have taken me like an hour or two. We're all going to have a virtual version of ourselves. And I think
that's incredible.
Like just like you bring a laptop to work, you bring your virtual agent to work, or we give you one from our company. I think it will become at that level. It's just part of your workflow because the companies, the people who use that will be so much more powerful than the others.
Welcome to the 10th episode of the podcast. I'm here with Iulian Serban at the offices of Korbit AI. Thank you for having me here.
Thank you. Thank you, Thomas, for having me.
Of course. So you hold a PhD in machine learning from AM.
I did my PhD, did a ton of research, and then graduated and then started building a company. So
wonderful.
I still do research sometimes, but it's not my vein.
Yeah. And now you're the founder of Korbit AI.
That's right.
Okay, wonderful. So before we get started, really, I'd love to dig in really, what is Korbit AI? What do you guys do here from a general standpoint for the...
So Korbit AI is, we're building a generative AI agent for engineering management, software engineering management. So helping software engineers build better software by reviewing the code, catching the bugs, and then helping the manager to track the progress, track what features they shipped and didn't ship, all kinds of operational reporting.
Okay.
So we build these kinds of tools. It's not where we started, but that's what we do today. And now we have literally thousands of developers using it, hundreds of customers, and are growing fast. So that's exciting.
Great. And just before we had started, you had asked me the question or topic, should we learn how to code? So I think it's a good place to start, although very important question nowadays with a lot of the AI tools, a lot of vibe coding we see going on. Me, myself, when I find myself using these tools, you almost start to lose the understanding of the code infrastructure yourself. So what are your thoughts on, should we learn how to code for somebody that's already technical and someone that wants to get into development?
When you say someone that's already technical, you mean someone that already knows how to code?
Yeah.
I think they should keep doing some of it and not lose their skill.
Yeah.
But I think for new students, there's value in learning the basic principles, the foundation of software engineering, computer science, algorithms, data structures. It will put you leaps ahead of people who just do vibe coding. But maybe you won't have to actually use a lot of it in practice, but you understand the underlying design, underlying technology better. But it is a good question. And what does it mean then? Like what skills should you learn? Because traditionally a CS degree is 5 years. Do you really need 5 years?
Mm-hmm.
Where do you spend your time in those 5 years? I don't really know if anyone has a good answer to that.
Mm-hmm. We're actually down the street from Le Wagon, which is a boot camp or like an institution that does courses on computer science, learning. And I guess it's a shorter version of a university degree and to some extent could be more manageable for someone trying to break into tech while not having to spend 4 years and, 4 years of tuition fees on the university degree, where a lot of the courses, myself as a CS graduate can tell you, like, it's not all relevant to what you're going to be doing in real life.
I think that's true. But even before vibe coding and ChatGPT, right?
Yeah.
Most of what you learned was not going to be applicable.
Mm-hmm.
But learning the way of thinking and reasoning was still very important. I think Le Wagon, we actually worked with them some years ago. We had some courses. So they ran their courses and they used the AI teacher we had built before and then offered it to their students. And it's an interesting program that they run. But it is, of course, not as deep as a CS degree. It is a more applied program, teaching you like web development or basic data science skills.
Yeah, it's a lot of hands-on projects, I guess.
Yes, yes.
Yeah.
Very hands-on and maybe avoiding some of the hard theory.
Yeah.
And so it's easy to get an entry into the market, but it's not gonna make you sort of the key architect behind a big system. It's just gonna land you your first job. If you work really hard and complete everything, then it will land your first job. But also many of these programs have it's hard to actually learn the skills in like 3 months or 6 months or whatever it is. It takes a lot of effort. Unless you already have some background in tech, it's hard.
Yeah. How did you get started in tech? And did you start, we hear a lot of stories of people starting to code at like, 6, 10 years old, building a website when they were not even able to.
Yeah. I actually had a story like that. When I was maybe 12 or 13, my dad, who was working at the local high school, he brought home a book about Visual Basic.
Okay.
And it had the CDs and everything. And I was just curious and I installed it and I did my first Hello World. Before that, I had played games and I knew how to install games. This was like 2000 something. And so I was very used to like pop in a CD, play a game. Now I popped in a CD and then an IDE came up. Yeah. And then there was a tutorial on how to do something with it. And so I learned like that by myself at first. And I actually got my first job coding when I was 15 or 16 at a website called Rent a Coder.
Okay.
So you could do these freelance projects and I was earning 3 times more money than I did working in the supermarket. Sorry. So that was fun. Yeah. So I learned at not 8 years, 10 years, but I was like 12, 13 or something when I really started. And then I got my first job when I was 15.
Okay. Wow. So very early on, yeah.
Yes, pretty early on. There's nothing that really stops kids from doing this because a lot of programming is simpler than playing chess or some other things that 10-year-olds can do. I think it's not really, I don't know why you shouldn't be able to do coding when you're 10 or 12 if you want to, if you think it makes sense. And I think these days kids start even in their schools where they run this. There's Kids Coach NS, right? They target like 12-year-olds as well. So there's nothing stopping kids from learning coding. It's just another skill, like anything else, like painting, like math, like you can learn it.
I had an interesting conversation with actually, I think she was a co-founder with Kids Coach NS on this podcast. And the reason she obviously started it was this concept of literacy in technology. And she thought that, obviously learning how to code at a young age is, just as, if not more important nowadays with basic literacy skills. And it puts you ahead a lot in terms of, just being very competent with technologies, being able to tell your story and not necessarily having to go into an engineering job afterwards, but the fact that you understand from a basic level how these technologies work. So very valuable, I'd say.
I think that's true. It changes your role from being a consumer of the technology to being a builder, a creator with it. And
so what did you first build in? You got the IDE, and then what was your first project you wanted to do?
I did a lot of small projects, but the first big project I really tried was like building my own game. So I downloaded a Visual Basic 3D engine and I tried to build it, and it turned out to be too hard. But I was able to render 3D objects, which is cool. So I loaded them in and I was rendering them, but I couldn't really make them move more. It was just a ton of work.
Yeah. The other day there was a demo event and this guy was demoing Frogger. He had done essentially a Frogger where it would take your camera, kind of like Crossy Road, the game where the frog jumps over the street and everything, except you have to turn your head left and right to move left and right, and then open your mouth to move forward. And so just like very basic, connecting that with the camera and like the understanding of like your movement and your face and everything. And it works like very well. So I was playing with it the other day.
Was it a virtual reality setup or
no, it just takes like your camera from the laptop.
And
then it just shows you the position of the frog in the game.
That's funny. Yeah.
But it's funny because he wasn't from a technical background, so you'd able to was able to learn it like relatively quickly and then kind of build it out.
It's also very creative. You use your body instead to
Yeah.
play the game instead of hands and keyboards and mice. Yeah.
I'm sure eventually we'll have virtual reality and entire kind of world, like, Ready Player One kind of
Yes.
situation
Like the movie.
where you're playing the entire game, but you're moving at the same time.
Yes. That will be an amazing, but also a bit scary world.
It would be. It would be.
Yeah.
Well, going back to, your early days in technology, then you went into studying computer science, and then followed up with a PhD.
Actually, I started studying math.
Okay, right.
So I'm from Denmark, and my University of Copenhagen, I wanted to really study AI. And I had already done a few projects by the time I was 18 in AI, but there was no master's or undergrad program for AI. The closest was math and stats. And there was I think one course per year at the time. This was 2008 or something. So a long time ago. And so I studied math and stats, and then later I did a master's in computational statistics and machine learning. And then in my PhD, came here to Montreal, I then learned computer science sort of as a side thing, because my PhD was technically part of the computer science department. And so I never actually formally studied computer science. I learned as a kid to code, and then I went the very theoretical, mathy way, and then I came back to learning it.
What do you think going that theoretical route? A lot of people do math and CS or come from, from a physics background.
Yeah.
What do they bring to the table that, somebody that just does software engineering or sciences, but not the theoretical mathematical part?
I think they take a much more systemic approach. Like physicists and mathematicians are much better at thinking about complex systems, and most of the design patterns in CS are actually very simple patterns, and you just get them right away. So they will come, these people who majored in math or physics will come with very strong backgrounds like that, but then maybe they'll struggle in actually building the application quickly or testing it and getting into the flow, because they will overthink the simple problem and build something very complex.
Do you find yourself overthinking small problems once in a while? That's what your team has to kind of
Yes, especially when I was younger.
Yeah.
That was one of the hard things to do. You sort of take out a huge sledgehammer when you just have a little nail.
Yeah.
You overcomplicate things. There's no need to.
So what would be your advice for somebody trying to develop anything, where like a game or something, but they tend to overthink? What should they focus on?
Oh, I mean, I think that's a problem for researchers and people with very strong theoretical background, because that's also kind of their comfort space, thinking about the problem, writing things down. So yeah, I think it's obvious they need to just build the simplest version and iterate from there, right? They need to think like that. They need to change the way of approaching the problem. I think most things that we have to build today, we don't know. We don't understand what the right solution is. We don't understand the constraints. And so you almost always want to do very iterative, rapid development. You build a small version, you test it, you build a slightly bigger version, you test, build a slightly bigger version, and then you get feedback from customers or users or whatever. So I think that's the de facto normal way of building. And it's very different from research, where you spend months hammering at a problem just on your own. So yeah, I think that's probably one of the big differences.
And you yourself made a switch really from the research side going into entrepreneurship, or developing at least products.
Yeah.
Could you tell me more about, that switch? What was the reason that you made that pivot? What was the opportunity?
Yeah, that was a huge pivot.
Yeah.
So I had spent 5 years doing my PhD with the famous Yoshua Bengio. I had written 20 research papers. I co-authored a book with other people, and we'd just been, and I think it was hard because I think I'd done a pretty good job as a researcher. And when you then turn entrepreneur, you have to unlearn a lot of those. Like, what makes you a successful researcher does not make you a successful entrepreneur. And yeah, one example was this problem of overthinking it. The other thing I ran into pretty quickly is, so we we started the company around 2018, 2019. We raised funds, we started hiring people. And the first few people I hired, I managed them sort of like research. And the reason I did that is because the labs I had been in, I had been at the McGill RL Learning Lab with Joel Pinot, and I had been in Yoshua's lab, Mila, and now they're sort of merged. Back then they were a little bit separate. And the role model I had was, how do they run these labs? That it's like, that's good science. Yeah. Maybe I can, we're building a technology in this company. We should also be doing good science. And so I was sort of mimicking. Right, I think that's natural. People always mimic what they see in other places. Of course. And so I was mimicking a research culture, and that led us to actually publish a lot of papers initially and explore many ideas, but made it hard for our startup to build a production system that was fast and scalable and all these things. And so that was one of the learnings, not like to basically what you want to do is build a product organization because we were a product-led startup. Like, so you want to build a product organization, not a research organization. Right. And that changes how you think about who you hire, how you assign tasks, how you divide responsibilities, how you test things. Everything changes by that.
Must have been a whole learning process, and I'm sure you're still learning things every day here.
Yes.
On the differences between from the research background and now from the product-based environment where you're actually just selling things to consumers, and it's not for the sake of uncovering some solution.
Yes.
Within the complex problem that you're working.
But I also think you need a bit of both in the org. And so at Korbit, even though we are much more a product org now, we still have like a research arm. Like, it's like, it will be like 2 people. Often I'm one of them. And we go and build a research project for a month or 2 about a harder problem to tackle. We find a solution and then we productize it. So you still sometimes need that, because when you're very product oriented and you ship fast, sometimes you cannot tackle the hard problems. There is no like low hanging fruit, or you need to think bigger and solve the harder problem. So you probably need a bit of both. And then you need to manage like how different people have different roles. Like, this engineer is shipping every week. This other person ships in 2 months. Yeah. Different timelines, different expectations, different skill sets. And you have to manage that.
Yeah, I'm sure it's a lot of things that they don't like. You kind of just have to learn on the job and develop your own systems for that. But I guess doing the research helps you innovate more, gets you problems that you can solve, and also satisfy that research appetite and the complex thinking and trying to uncover really something new. Whereas the other product section is a lot more consumer based and iterating fast, as you were saying.
Yes, exactly. Yeah. Exactly.
So what was the first iteration of Korbit? It obviously didn't look like Korbit.
It was not a Gen AI agent for engineering management. It was really an AI teacher.
Okay.
And so the original vision was, and this was back in 2018, 2019. So NLP models were getting really good. You started to have like BART models. You started to have early transformer models that could generate entire sentences or paragraphs. And they could start to understand like they could start to do Q&A, like simple questions and answers. And so we looked at that and we thought, me and my co-founders thought like, hey, there's a huge opportunity in education. And so we knew like platforms like Coursera, like Udemy, like OpenEdX, and we saw there's like tens of thousands of courses, hundreds of millions of students like going to these platforms, and all they get is video after video after video. And we thought we could do a better job. Hey, what if we could create a lesson for you? What if we could create like exercises? What if we could generate feedback? What if we could answer your questions? What if we could do all these things? What if we could give you your own teacher? And so instead of having 100 million students watching videos, there'd be 100 million students being taught by 100 million AI teachers. So every student would have their own teacher. Could we change education? And so we had this very bold vision of doing that. And then very early on, we're very lucky. We got connected with Khosla, who is this very famous entrepreneur who funded Sun Microsystems many years ago. And he had a thesis on this. Like, he had written a blog post about how AI will change education. I think the statement was like, AI will replace teachers.
Okay.
And not exactly replace like one-to-one, but completely change the way teaching is done. And when he met us and saw our vision, that was like almost a hurt. And so he invested in us and gave us the opportunity to start building it. And he connected us with many different people, all the way from like Founders Fund to Bill Gates, and helped us like network and fundraise and do all these things. And so we started building the AI teacher, and within basically a year of getting the first funding, we already had 1,000 students on the platform, and another year later, we had 20,000 students or something. And so we got more and more students, and they were using it, and we were getting data, and with every new student, we got a different learning path, we got more data, and we were able to improve our systems and personalize more.
I suppose that's a big competitive advantage nowadays, especially the influx of data that you get, from a certain product, and you better understand how the consumer actually uses it, and therefore you refine your own systems. And
yes,
it's something that other people obviously don't have access to. But you guys focus primarily on, was it data engineering learning and like software learning for?
Yeah, when we started building the AI teacher, we needed some content, and we decided, well, actually we built a first mini course on global warming, and we had some stuff on basic biology, I think photosynthesis and stuff. But then like my background and my co-founder Katerina's background it was really about computer science, machine learning. And so it was always an extra hassle to like, okay, now we got to remember all these concepts in biology, figure it out, remember the right way to explain them technically. And so that was like just an added burden. So we decided, let's go into let's just teach computer science. Anyway, there's huge demands for it. Yeah. So we started teaching computer science, data science, machine learning skills. And then I brought in Yoshua Bengio and a few other professors to teach. Laurent Chalin, who is now I think the director of Mila. And so I brought in a couple of teachers. They helped create these courses. They shot a bunch of videos, and then they became part of the content library. And then the AI teacher would take that and create the learning paths from it.
And so it was an iterative process, right, with the feedback, and every, I guess, milestone in the learning journey had certain quizzes and interactions with the agents, you would call it. And therefore you would find, the performance of the student compared to a certain baseline, perhaps, and just figure out what are the learning steps that they are missing in the understanding. And so create a new roadmap for them, or, revise some topics.
In fact, right at the beginning, there was about a 15-20 minute quiz they had to do. There was a pre-assessment, and that would create the initial learning path. Because you can't just start from random. Like, of course, if you know nothing. So we did that investment, and it was also a good filter. If you're not serious about using our learning platform, you'd get filtered out. And so we did that. That created the initial learning path, and then there was a recommender system that would then update what is the next item afterwards. And that recommender system initially was based on a set of features and more rule-oriented, and later it became RL-based. We had a contextual bandit algorithms that was learning like from a whole set of features about the student, and then maximizing their completion rate of that module. Like, will you finish this module? And actually, it started working really well. It was able to learn common strategies like, oh, I see you got this question wrong. That's because you have this misconception. Let me teach you that thing. It started learning those patterns, and that was really interesting. That's kind of the intuition a teacher builds. And now it was just learning it from thousands of students.
But the general vision of, and I guess from Khosla as well, from AI replacing teachers, obviously directly, the teacher role is going to be modified and changed in some way, of course. But I think it's an enormous opportunity for students, first of all, just to have access to education in general. Now that we all have, at the touch of our fingers, access to, such powerful machines, we can make it, into a tutor and give us certain course recommendations, for example, and learning a certain topic. It's going back to the idea of like Bloom's 2 Sigma problem, and the concept that if everybody has a dedicated tutor, a one-on-one tutor, that you essentially increase the performance, I think, by 2 standard deviations. So like medium, poor students become above average students become exceptional students, and average students become very good.
And basically move to the top 5th percentile of students.
Right. And so how do you see that playing out nowadays, now that, technology has developed so much, even since you guys started developing your system, because ChatGPT didn't exist at that time, of course. A lot of these large language models weren't as performant.
Yeah.
And so what are the differences from, 6, 7 years ago compared to now? And what should we expect for the education system?
Well, I think that, the technology has made huge progress.
Yeah.
So the technology to build this is definitely there. But the opportunity to abuse it, misuse it is also there. And I think if students, let's say hypothetically, a student just doesn't want to write their essay, they just asks ChatGPT to write it for them, and they just vibe code their essay, then their learning will probably be smaller if they use the technology that way than if they had done the traditional method of having to think through a problem and write an essay.
Yeah.
So I think I think that technology could hurt them, but it could also help them. The basic technology itself is not good or evil. It's just technology, and the way we use it that changes the outcome.
Of course, it's not inherently bad.
Yeah.
The way you use it could be, better or worse based on context.
And I think many schools and universities don't know how to do it. And so the classic example was New York State banned ChatGPT when it came out and said you just can't use it in any public school.
Yeah.
And that's just the reaction of we don't know what else to do. We don't understand it. Let's just ban it. Is that even enforceable? I don't know. What's the consequences? Do some students use it anyway and cheat? And how does it skew distribution? It causes all kinds of other problems. But in theory, even if you could enforce it, it's still a pretty silly strategy. And if you think about the analogy to healthcare, when we have a new technology in healthcare, we try to get it, do the clinical trials and push it out as quickly as possible and let people benefit from it, even if it's life and death, even if there are side effects and sometimes the treatments don't work, we still want the biggest effect. Mm-hmm. In education, it was always sort of the laggard, let's take it easy. Yes, there's a much better thing, but we need to take it slow and test it. And so it's interesting how people are very conservative. Now, that's not every university, every school, they're all different. They all have different approaches, but there's definitely a group of them that were scared of it and just want to shut it off.
Mm-hmm. It also comes down to the different types of education. Going back to Kate Arthur from Kids Coach Jeunesse, she talks about 3 types of education: formal, informal, and non-formal. So the formal education would be, your institutions, your universities. The informal and the non-formal are things you learn on the day-to-day, doing it yourself, so learning things yourself. A lot of people now, they self-teach, for example, science or a lot of topics.
Yeah.
But then there's also a question of how are you recognized for this? How can you then use these skills in the future and, present them to someone from an employer, for example? So there's many questions, but I think inherently it's good. It's difficult to implement it directly into, the large scale universities, educational institutions. That's why we see a lot of boot camps, a lot of smaller, more agile groups that are implementing these, and then people also teaching individuals how to do it themselves, because I don't know, when you go down in size from educational institutions to boot camps to smaller groups, and then eventually it just goes down to the individual. So we all have to be able to learn ourselves and evaluate, is this tool relevant to how I should learn something? Should I use it? All these things. So which is
these are all high problems. And one of the main values university have is they're basically a filtering mechanism. Like a university like McGill, which has a very high bar for accepting students, it filters out. And so just the fact that you got accepted to McGill shows that you belong to the top nth percentile. And it's not necessarily that the teaching is better there. Maybe sometimes it is, but not universally. But the fact that you got into McGill is the signaling factor. And then you get the degree from McGill. And that is a lot of the value. It's not that someone could be self-taught, but they're missing the signaling value. And so you can't tell yourself apart. And there were studies on looking at people who got into the prestigious Ivy League universities in the US, like Harvard. And they saw they did a study, people who got accepted to an Ivy League one and a local college, like they got accepted to both, and they chose the local college, and they compared that group to the people who chose the Ivy League one, and they looked at their earnings throughout life, and it was the same amount of earning. It was like no statistical difference. But in that way, you could control for it. While if you looked at the people who just got into the local college, but were never accepted, their earning, of course, was a lot lower than the Ivy League one. And so it was really, the filtering was just a big part of the mechanism. And that has nothing to do with the learning that the institution provides. It's just society needs a way to rank people and filter. And so these technologies.
I would hope that they teach a little bit better at Harvard than our local college, but
not necessarily, because it could be that the professors are so obsessed with their research. And maybe they're great researchers, but they're not good teachers. Yeah. It's a common problem. Or that the degree you get into there is not what they're famous for. So like maybe it's a good university, but that department has very little funding. But still, it's a good signal for you to have gone to Harvard.
Right. And I suppose perhaps some of the network effects and the social effects of having gone to Harvard, you meet a lot of other people that gives you, access to opportunity. I'm sure it's, I don't know the exact statistics, but it's graduates from Harvard that, I don't know, compared to the number of people that start successful startups or something in relation
it's
to
probably higher
university that they have gone to. Maybe that has an effect, but I mean, going back.
But is it causal, or just the people who want to build startups went to Harvard because they know that there's a good accelerator and good network? And it's hard. And if you filter by program, because you have the MBA as well, that's very famous, right? But if you look at, I don't know, biology at Harvard, maybe the percentage of entrepreneurs there is the same as any other university.
Right.
But if that's the role of universities, to filter and rank people and give a certificate, if the education is just 10% better, then it's not, that's not the problem that this technology would solve. It would sort of benefit all institutions equally if they want to use it.
But at least I guess, what was the name, by the way, of the projects for teaching data engineering? The whole roadmap?
I mean, it was called Korbit too. The Korbit.
It was called Korbit as well. Okay.
Korbit AI tutor. Yeah.
Okay.
So we kept the name.
And then what happened when you pivoted into this? I'm sure there was probably a few intermediary steps as well. What was that phase from starting to realize that perhaps, the problem you were solving was not adaptive, or the solution you were giving? What happened?
So at the height of it, we had like 20,000 students who had signed up and were using the Korbit AI teacher, but they were all free students, free users. And then we had about a few thousand, 1,000, 2,000 like employees and companies. So first we pivoted towards the employees. Let's upskill the software developers in data science, and let's upskill the data scientists in software development. So we were targeting those, and we had companies in Montreal using it. But it was often relegated to like the learning and development or HR department. Like it's a benefit, like here you can go learn a new skill on Korbit alongside like your healthcare benefits or massage therapy or whatever. Like you had all these benefits the company offers, and Korbit was somewhere in that list. And so it was a bit strange, and it wasn't really integrated in their work. And so some people used it a lot, but most people didn't. And so it was not really, like we could see from the engagement and the usage, it wasn't really helping them. And we had this like amazing example, like that was just surprised us all, where there was a person in a company that was a director of marketing, and he did data science, take all the data science modules, and 3 months later, we check in with the company and ask, hey, we saw you have this super user here, how's it going? And then he had quit his job to become a data scientist. And then we had created negative value for maybe positive for the individual, but negative for the company. So why would they pay us?
So you're selling to the company, not to the user.
Yes, exactly. And our promise was they get better skills in their work now, not to transition to another job.
Right. It's like as the value wasn't directly, there was a bit of a mismatch between the value that you were getting to the end user, that is the person using your software and learning this data science module, and the company that was actually paying for it to be used by their staff.
Yes, exactly. There's a mismatch there. And this happens in many companies. What people want to learn is not the hours need for their job.
Yeah.
And people often, like, they try to change jobs, they try to level up, they try to switch career paths, and they don't want to tell their boss and their team, so they do it on the side, or they try to find ways to do it. So it is a bit of a tricky thing. They should do it, but it's also like, should the company invest in it? And it depends. Some companies are good at like putting you on a track. Some larger companies, I think AT&T have programs like that where, oh, if you work really hard, we will support you with X, Y, Z. So they will run like, oh, you can have this evening course teaching you how to become a data scientist, and you can go literally from, I think, customer success to data science.
Okay.
It takes like, I don't know, a year, and you have to work also in your free time, weekends and evenings, but you can go on that path, and then they will place you at a job at the entry level. And so some companies can do this. Most companies don't have the resources, don't even have the mindset.
Yeah, I know some companies, I'm not sure if it was Google or another one, you get like 20% of your time to dedicate it to whatever you wanted to, and you're getting paid for it, I think, at the same time.
Yeah,
so
Google.
You're getting, learning for data science. You want to become a data scientist.
Yeah.
And that's like a fifth of your time, which is actually like a decent amount. But then I don't know how that would translate into actually, if you want to transition into a different role. But it's a good, flexible pathway so that you can look at other opportunities.
Yes.
And all of this.
I think that happens often in startups too, just informally. Like people, they do a side project and they try out things, and mostly it doesn't work out, but sometimes it does.
Yeah.
They put it into the product, or maybe they learn a new skill, but it happens in many companies. But Google is the famous one that went out and said, you will have 20%, like 1 day a week, to do whatever you want.
Yeah, I was at a talk with somebody from Google that said that. Now I didn't know about that. Wow, that's incredible.
Someone at Google didn't know about it.
No, I didn't know about it.
You didn't know?
Google was telling me about it.
I see.
And I was like, wow, that's so cool.
But also, like, people in the US, right, in Silicon Valley that work for Google are probably generally expected to work more than 40 hours anyway. It's kind of easy to say that you get 20% off, but you still have a workload that's 50 hours. It's not a one-to-one necessarily.
And so you've pivoted into code management, code checking. Why is that problem, pertinent? What is the problem you're really solving for industries and development teams?
Yeah. So with the learning platform we had with the AI teacher, the main feedback we were getting from the engineering managers, from the VPs, the CTOs was, you're not learning the right things over here. Like, my engineers are going to Korbit and they're not learning the things they need. And I wish you would just be in my workflow, look at the current task, and then teach that. That was the main feedback we got. Basically, get into the workflow of the engineer.
Okay.
And so we took that, and what we did is, and we talk about pivots, but pivots are like months long, or sometimes several quarters of work. And so we built a couple of POCs, and one of them was a code review one, where we built a GitHub plugin. And what it would do is it would scan your pull request, and then it would see what libraries you use. Like, oh, you're using scikit-learn. Oh, you're trying to build a linear regression model. And then it would take that, and then it would generate this mini 5-minute tutorial for you. And then we did that. And then a side product of that was that it would sometimes find bugs, like, oh, you're building a linear regression model, but your output variable is binary. So maybe that's not the right model. You need a classification model instead. And so we started finding these bugs as a side thing. We put them at the bottom of the PR when we found them. And then developers looked at it and say, I don't care about the tutorial, but I'm happy you found the bug there. That saved my ass. And so we then sort of pivoted again and then doubled down on the bugs. And so it was a series of POCs and testing. And we frankly got surprised a bunch of times that this is what they really wanted. We didn't fully understand their workflow in the PR review. We didn't understand the value of it. But once we had found a bunch of examples like that, the value went up a lot. So we doubled down on it, and then we quickly learned, hey, not all bugs are equal. Like nitpicks, like you have a typo here, or you're missing a comment, those value are much less valuable versus this thing will crash, or there's a security vulnerability. Like those things are much more valuable. Like a bug like that alone could be worth $1,000. Like if I knew, like, you have a major security vulnerability in your code, like how much money would you pay me to fix it for you? Like, maybe if you're a big company, maybe you pay tens of thousands of dollars for
even millions when it comes to, I think there was a story in high frequency trading.
There
was a bug where essentially you're doing the opposite of like instead of buying and reselling. And I think in the span of like not even a few seconds, they had essentially bankrupted the entire company. I have to find the exact name, but it was like millions of dollars and a massive consequence because of one slight bug. And I suppose if they had Korbit,
somebody changed a plus to a minus or something.
Or there was something wrong in the logic where it wouldn't stop. There's no stop loss or something. I'm not sure exactly the details, but it's true. I guess it's a testament to the fact that you don't necessarily understand the pain points until you get that iteration and that feedback by shipping it to consumers, to your end users, and really understanding what they want to get from your software. What do they enjoy? What do they don't like?
Yes.
Did you guys go and ask them questions directly, or how did you get that feedback from the users?
We did. We did a lot of design sessions.
Yeah.
We hired an agency that went out and actually called up VPs and engineering managers and then scheduled calls.
Interesting.
And then at first we had a list of questions and we would ask them, what are your biggest problems? What are the biggest pain points? Then we had a set of mock-ups. And then the second set of interviews were like, okay, here's a mock-up of like Korbit in PR, doing a code review. Here's a mock-up of Korbit in ID. So we had different mock-ups. And then at the later stage, we finally had the actual POC. They could install it on a test repo and try it. So it was a process like that. And it took months to do it.
There's an interesting idea of doing that kind of agency model where you contact the users and ask for their feedback. And now you do it with like an AI caller agent where you just have the person, kind of vent about the product and what they enjoyed, what they didn't enjoy, but, relatively open-ended. So you don't actually create any biases. And then you synthesize all the information because you can do a huge amount of volume because it's, so much cheaper than having to hire someone to do that. And then you find out things that you would probably not find out earlier. It's also a faster iteration process. But then, there's obviously some issues with that, but like it's interesting application of just getting feedback quicker with like that.
That's true. What's the scope of your interviews? Is it very broad, like everything in your job? Tell us about it and what your problems are, or do you narrow it down? Tell me about the PR review process and bugs and where do you need help here? Like you can narrow it. And I think this is one of the skills you have to learn when you do product management and design thinking, like how to interview people and get the information. And the other skill is people won't always tell you what the problem is. They will tell you what they think the problem is. And sometimes they won't even tell you what they think. Sometimes they don't tell you what you want to hear.
Right. There's a good book I heard, The Mom Test.
Yeah.
Which kind of guides you through how to ask questions and really uncover the problems without, expecting the answers directly. And because if you're asking, very specific questions, which are, what's the term for that? Like loaded phrases and loaded questions, you just get the same answer every time because the question is inherent. But yeah, so
isn't the mom test you have to imagine you asked your mom?
Yeah. But
if your mom would just say yes, then it's not a good question. There's
something along those lines. I know there's like a small like book or documentation on that. It's a bit of a guide on how to take the question, but that's the idea.
You can't get honest feedback from your parents. Don't ask your mom about your startup.
I have a friend who's doing actually a startup with his mom. They're both co-founders. I know it's interesting.
There are exceptions,
but they're doing relatively well. So they're working well together. But so you pivoted from the learning part to now code reviews and finding bugs.
Yeah.
And so now what's the current stage that you're at with Korbit, and what are the next steps as well?
Yeah. So last summer in July, we officially launched the product. It came live. Anyone could sign up. Now we have about 140 customers. We have some very large enterprises using it, Fortune 500 companies. So we're growing fast.
Yeah.
And we do literally hundreds of reviews every day, if not every hour now. So there's a lot of things happening. So it's growing fast, but it's also a very competitive space. Obviously, there's a lot of players going in. There's GitHub Copilot, there's Cursor. We have 5 other competitors doing code reviews as well. And so everyone is sort of flocking to this like a gold rush almost. And so we are looking at, of course, how do we differentiate? What is the niche that we can play in? And what we've been very good at so far was helping the engineering managers. So there's there's the developer who builds a feature and they do code review, but then there's the manager who needs to manage the team, manage the deliverable, do performance management, organize all of it, and also generally just level up the team, level up the code. And so we built out the second product, which is the DevOps agent. It basically does this operational reporting for the manager. So like summarize all the security vulnerabilities in the last 3 months. It will just generate that list and you can look at it. Or I have a one-on-one coming up with Joe in an hour. Can you summarize everything he worked on and what I should discuss with him? And so Korbit will go in and do that and prepare them at it. And so we're targeting more and more the manager. And then we're also starting to work on like thinking about the organization as a whole, like policies and rules and requirements. Can we take, like, if you need to be SOC 2 compliant, can we take that and inject it into the code review process? If you need to be HIPAA compliant, if you need to, you're building this on an embedded device and there are memory constraints, just to give you another example, like, so you have X amount of memory or power, can we review the code and help you with that? So finding ways we can help the entire team work, as opposed to many of these tools that like Cursor are like for individuals. They target the individual dev. We want to help the team and be at that level. So we're looking at that. We have something that's pretty different, but we're not done yet. There's a lot more work.
And I suppose you guys use it internally as well in the development.
Yes, we dog food it every day. Yeah, of course. Everyone has to use it. And if there's something you don't like, you should speak up about it. Like,
so you're your first user.
yes, that's right. And that's both good and bad, because you get a lot of feedback, but also you get like group thinking bias. Like people negotiate and like there's just like we discuss sometimes titles or way to present things, and then we discuss it for a week, and then everyone ends up agreeing this is great. We put it in front of customers, and then they're like, this is terrible. It's way too much text. And so, but we had like group thinking going on because we're all like one sport. So you have to, dogfooding is great, but it also has drawbacks. It's not perfect. You still need customer feedback as quickly as possible.
But in a sense, you're, enhancing the role of the manager to doing things that previously would have taken hours, if not things that they wouldn't even been able to have done before. For a specific person or developer, what have they done in the past, couple of months, and what are the performance reviews for that person? So
we can help with performance reviews. We help with sort of the objective facts, or like what did they deliver, what features did they ship, what bugs did they make, what bugs did they fix. It's up to the manager to then take that and then make the actual performance review. So we don't give you an evaluation of where the person is at. And we're careful not to be that big brother watching you all the time. Although I think the space is heading towards that. If you can, before, like we had very dumb metrics. People would look at like, number of lines edited, or unit tests cover it, or the time to ship a feature, the time to burn down a sprint plan, or like we had very dumb things, and you could game these very easily. Like, let's say you want to show I fix a lot of bugs, you could just write a lot of code with a lot of bugs and fix them very quickly, and then you could like game it, or you could just write, if you just wanted maximize number of lines, just have many lines, add a lot of doc strings, and you can pad your things. But now the AI can actually understand semantically what happened. You built this thing, but you went back 3 times to refactor it, and there was a bug in production. You can see those patterns, and so I think these reporting mechanisms will get better and better. And I think in a way it's kind of scary, but in a way it's also more objective, because historically what's happened is engineering manager had to guess. They had to use their intuition and guess. And when that happens, biases play a much bigger role. And so there was always kind of a gender bias, a race bias, and seniority bias. Like, Joe is the senior developer. You could possibly have made that bug, but Peter is their junior. It's probably his fault. There were all these biases coming in, and now we can be a bit more objective, although we bring another set of biases from the algorithms. So I think we're heading to a world like that. But at the same time, probably also a world where one developer just does a lot more and has more responsibilities, because they can literally prompt their way to building an entire application. They tell like Cursor, like build this, build that, and then it just starts writing thousands of lines of code.
So I suppose you could use that for your smaller agents that you're deploying. Eventually, it's almost like the individual itself will become the manager. Is that something that is it viable?
Yeah, everyone manages their own group of AI agents.
Yeah.
This is a concept that's appearing.
Yeah.
You still have to coordinate across different functions. It's not clear, but humans are sort of moving up the ladder. And so you could think of it as 50 years ago, we were writing assembly code, and we started writing C++ code and Python, and now we're writing prompts that write these other things. So you can think of the LLM as just a way of compiling your vague natural language instructions to code that compiles to machine code. But that's not exactly it, because there's a feedback loop and a lot more happening. But that's one perspective.
So we're nearing the end of time. I don't know if you have a hard stop as well.
No, we can take a few more minutes.
Okay. Because I want to go back to that concept of or the vision of the Big Brother movement, as things are becoming more. We're using more and more agents, more and more tools in everything we do. We're delegating a lot. And so we need perhaps more supervision in the actions that we delegate. And so naturally we tend to have this Big Brother kind of situation happening where, we're allowing our access or the actions that we do are being watched and monitored and logged of the stage. Is that something that you think is, I wouldn't call it an unstoppable trend, or more of a general trend? What are some of the things we have to look out for going in this direction?
Yeah, that's a good question. I mean, there's a lot of biases that can be introduced, right? So depending on how we build solutions like that, is it fair to the employee? Is it accurate? We know the LLMs have biases already. There's lots of studies on you ask an LLM to create an org chart, and then at the top, the CEO is always going to be a man named John or Peter or something. So there's clearly a gender bias, and I wouldn't be surprised if reading the code, it infers from the username, oh, this is a man versus a woman, and there's just some expectations around skill sets here that it has learned in some way. And so I wouldn't be surprised if there are some biases here we need to watch out for very carefully.
How do you stop those biases from, exacerbating issues that currently exist? What actual mechanisms can people kind of think about or put in place to avoid those issues?
Well, you can measure accuracy of the information provided, right? So that's what we do with our operational report. So when we do a report for a developer, we check all the facts. You did a report on an engineer, let's say Joe, you look at everything he shipped, and we check, did it correctly report every item he shipped or not? And did it correctly report the bugs that were introduced and the bugs that were fixed? So you can check the accuracy. So you run benchmarks, you do proper machine learning evaluation. That's one way. That's if you take the factual approach. If you try to do a more subjective evaluation or a ranking of this employee versus others, that gets a lot harder. So now you need to get into sort of management theory of what's a good way of evaluating employees and ranking them and giving them feedback. So we're not in that space, but there's a lot more here. I think also you asked, is it unstoppable or a general trend? It is definitely a general trend that's coming. And it's kind of in a position where a manager in a year or two, if they don't use these tools, they'll be forced to. Because everyone else
there's such a huge competitive advantage in terms of productivity gains, in terms of actual augmentation of features that you can use directly. The manager becomes like a super manager of all the teams, and you spend his time doing other things.
I think now it's optional for people to use it, but I think in a year or two it becomes mandatory. It's as important as having
you think,
I think it's going to be very compulsory. You just can't not function without it.
Yeah. Well, what are some perhaps roles or situations in which the adoption of these tools becomes more important than others? I'm sure some roles, they're still going to be able to be safe in the next 10, 20 years. Well, what are some competitive advantages that are going to be arising? For example, the engineering manager within the next couple of years, if they don't adopt these solutions, they face a big risk of I don't know, losing their role or really getting outperformed by other.
Well, I think industries that are very regulated, like healthcare or defense, or embedded systems, they have a completely different standard, and humans just are gonna play for a while a much bigger role. So if, for example, if you're building software for on-device circuits, let's say, like you're building some chips that are going to be in a self-driving car to control some part of it, you typically need to be something that's called NISRA compliant. And there's a whole set of standards around C code that just in that kind of very tight, like critical path, you have to respect everything because you have power requirements, you have speed, you have safety. You need to function under many different kinds of conditions. You have to satisfy all of these things, and it's not clear at all whether these LLMs can even generate that kind of code. So humans in a very regulated area like that, or imagine if you're building drones or equipment for space missions or something like that. Those very regulated industries will have a much bigger human component versus someone building a web application that if it crashes, it's okay. It's like, or if it's a game, like people get upset and you reimburse them their money, it's not the end of the world. There's no red tape. I think so. I think there's definitely that area. I think the other segment is if you think about very complex systems, like think about Google's engine, there's like hundreds of components, and like literally in there are software developers at Google that spend all day looking at buffers and pointers in C++, because if they can make a 0.1% improvement, that saves Google $1 million a day in cost or whatever. Like, so there are very like high performance requirements.
Extremely low level code.
Yes, which is not necessarily compliance. But the usage to demand is very high. So you want humans to do that. You don't want an AI to write inefficient code, certainly not code that will break the system. So I think that's definitely part of it. I think also
sorry to interrupt, like it's going to kind of cut out all the middle, the kind of the middle ground between all the low level code and all the extremely compliant and regulated industries, as you were saying. So anything really in between where implications aren't as severe, and also the of a poor code, and also there's not as a regulated system straining it. In that case, then you're more at risk.
And that doesn't mean that you won't use AI. You'll still use AI, but as the human will continue to play a big role. You'll probably definitely want code reviews in there. That's even more important. But would you let the AI generate the code for you? And would you let the same type of developers go in? No, you probably want graduates in CS with very good like degrees and strong knowledge to go in and work on that. I think the other thing that's happening is product engineering is becoming a new term we'll use. So you're not a software engineer anymore. You're
more like a prototyper.
Prototyper, but no, it's not just prototyping. That's a part of it, but it's all the way thinking about the customer, the use case. What's the problem they're trying to solve, and bringing it into code, getting the feedback again, bringing it back into code. It's like you're no longer building a task, like implement button X. You're like building the feature and getting feedback. And so you're switching from being a software engineer to a product engineer. And I think the people that will flourish here will be the ones who can do that and who have at least the foundations of computer science to understand the algorithms and data structure. So I think, those are things that will happen, but also like, like Darwin said, it's the survival of the fittest. And it typically means here the most adaptive. So you have to be a fast learner. You have to learn a new technology. If there is a new technology in 3 months, a new way of doing it, you just have to learn it. You cannot go with what you did 1 or 2 years ago, certainly not 5 years ago. You have to adapt. And the people who don't adapt make it.
Yeah, especially when I heard this interesting phrase, when the only constant is change.
Yes,
the
exactly.
best thing to do is just to constantly adapt. So it's a great point. And something else I wanted to ask you is I was recently talking with an analyst, and a lot of the concerns that they were having with AI agents, the agentic systems coming into more, teams as we see here, not just engineers, but it's financial analysts, people like this, and the concept of being able to do like data triangulation and a lot of the tasks that analysts would previously do. What do you think are the differences or the things that still make the analyst important compared to an agent when it comes to doing a certain task? Like, is an agent capable of essentially replacing a typical analyst? whether it be a quant analyst, financial analyst?
Oh, that's a good question. I was about a month ago, I was doing some data science analysis work myself, and I used Replit. They have their own agents in there, and I was able to do the analysis in 5 minutes that would normally have taken me like an hour or two. Okay. So I did all the pre-processing and visualization. I just said, pre-process the data in this way, and it just wrote all the code. And then I said, plot this chart. And then it was a bar chart. And oh, that didn't make sense. Okay, change it to a scatter chart. And just one line prompting, and it just changed it. And so definitely accelerated me like 5-10x. Like it was in that order. This was just one task I was doing. So it's definitely doing that. I don't know if it could, I don't think, at least at this point, it would reason all the way to the product conclusions. Like, okay, what does this mean for the next we're building? But
I suppose then when you come into the issue, the first thing that comes to my mind, at least, is why not build an extra layer of abstraction where you have an additional, black box agent or whatever you want to call it that manages the sub agent system, which thinks more about the product level, so you essentially replicate the product engineer at this stage.
Yes.
And so what's stopping us from doing that? Is that something reasonable that that could,
That's a good question. I'm not sure there is much stopping us. Most of the product thinking is it tends to be short-term customer driven. Like the customer wanted this, or 5 customers gave us this feedback, and it's often about summarizing it and making a decision. It's not that complex. You don't need to do like very deep reasoning, have like huge chains of reasoning. You don't need it's not actually as complex as that. Many algorithms we build are much more complex than the product thinking.
I suppose because the product itself is also variable. The change that you make when you iterate on a certain product forces you to, delegate that information or relay that information rather to people in your team. And if you have an efficient system that does that within a agentic system, theoretically, like it could do at least, a decent work in coordinating all the different actions.
I think it could do a lot of work. Yeah. I don't think there's anything magical about product management that AI can't do. I think what we see, right, is when there's many steps of reasoning, then it gets really hard. Like an example would be like playing chess, but because it's so constrained, we can build other algorithms that are really good at chess. But if you needed to think 10, 20 steps ahead, that's something the LLM would struggle with. But that's not usually the case in product management. Most of the product management is like building it, testing it, accumulating information from a few customers, adding it back in the roadmap. It's not as complex, but there's an element of assigning and prioritizing. Like we can only do one of 3 things, and what's the ordering. So there's some things you need to understand the humans on the team and what they're good and bad at. But you could maybe observe that.
It's whether or not your workflow and how these agents work together, is that a variable aspect. Can you then rearrange the structure when you reassign somebody to a different task, or you create a routine based on this? That's, I think, some of the limitations that current systems with AI at least don't really have, is that when you can create a little market researcher, but then if you want to do something else now and you don't have to do market research, then this person or this agent isn't really as useful.
That's the other thing product managers have to do a lot of is like selling the ideas. Like they figure out what we need to build. Now they have to convince the team to do it. So they do a lot of soft management. And I don't know how the AI would do it. I guess it could argue, it could create like a mini video about why this is a very cool thing we need to build. But that's an important part of the role, like rallying the team, getting people excited about it. And
because you need that challenge, right, between ideas. Because if the founder thinks of something, doesn't necessarily mean that it's something that should be implemented or that should be used.
That's right.
But then it comes back to the user. And so something I heard recently was the concept. It was, unless Lindy AI, it's essentially like a workflow system where you can create your own automated AI workflows from like a no-code kind of standpoint. And talked about this concept of having virtual users. So instead of, gathering a focus group and shipping your products and getting feedback, perhaps as you were doing as well with, calling individuals within the company that were using the product. Now you have almost an iteration, like a virtual persona for your consumer and then you can give them your product and they would use it at scale. And obviously there are like constraints here. It should probably have different consumer profiles, some variability, and it should also relate to the actual person, like what, an engineer would actually do, what they would actually think about. And then do this at scale with volume, and it would be equivalent to, maybe 6 months of testing with beta users or with a focus group. And so you get that iteration essentially immediately nowadays, or theoretically with this. And so what are your thoughts on that being, some possibility in the future for product teams to, instead of having to, call up your engineer focus group, you just send it to your virtual focus group?
Yeah. For software testing, I think it could be very powerful.
Yeah.
You could throw 1,000, 10,000 virtual users at it and try all the different paths. And that could be very powerful. The virtual users, if they're just based on an LLM guessing, that's not adding new information necessarily. But if it could take a bunch of real interviews with your target users, ingest it, and then create the virtual profile, maybe there's value in that.
Yeah.
So yeah, I think there's a lot of space here. Like maybe there's a company that just goes out, a startup, great startup idea, just go out and build a lot of these virtual profiles, and then you pay for accessing them.
Yeah.
It's a very interesting idea.
Eventually, something else I envision is perhaps every person, right? You would have your own virtual user, and I would have my own virtual user.
Yes.
And then companies could then, contact you or the virtual user, and then ask for access to your profile, how you would think, and all this thing. And I think just the fact that we are eventually going to have our own virtual kind of persona, I think is not too far-fetched. But, it's just the fact that we can now have like a copy, a clone of oneself, which does different things. And it gives you ownership on what that person might do,
yes,
of course. But yeah, what are your thoughts on that?
I think that's going to happen very soon. We're all going to have a virtual version of ourselves. And I think
that's incredible.
And you will give it access to your emails and stuff, but then there will be a barrier. Like it won't share confidential information, but it will know like everything you learn from these podcasts. It would have that knowledge.
Yeah.
It would be able to bring it up in future conversations. And so it would be different from other agents. I think it's going to happen. There's this thing called like an expert marketplace. You can basically pay experts for like, let's say I want to understand something about biology. I pay an expert an hour of their time, and then I get to question them about it. And this is just one use case of that. Like then you could just have your virtual agent be there, and you could sort of make some money off your knowledge.
Yeah.
I think it will become, it's the kind of thing where at first it will be a slow adoption, and then in 2 or 3 years, it will be like mandatory. Like you want to go to a job interview, your virtual person will go first. And if they don't make it, then you don't get to the real live interview or something. And then you start a job, and then everyone just expects like you're supposed to hook in your virtual agent. Part of it, like just like you bring a laptop to work, you bring your virtual agent to work, or we give you one from our company. I think it will become at that level. It's just part of your workflow, because the companies, the people who use that will be so much more powerful than the others. So the market dynamics will basically squeeze out the people who don't.
Wow. If you take that any further, I mean, eventually you just get to the idea that, or the simulation concept and the internet world, the fact that if we can create a virtual user, what's stopping them from creating their own virtual user?
Yes.
So then, I mean, it gets pretty far-fetched, but like, I think just the fact that we'll have some kind of, virtual persona, and I don't think that's...
But what's the value of creating another one? Well, just having 5 for yourself, or paralyzing the one. Because if there's no new information, there you have some unique information you personally, you could teach an agent. That agent teaching another agent wouldn't do anything you couldn't.
Okay.
So right, I think that's the limiting factor. Like to me, there's no difference between agents making more agents versus you making them.
Yeah. That's true.
But it does. Yeah, it is a strange future. And one of the concerns people have in the, I don't know if you follow the AI safety space. And
I try to, but it's obviously there's a lot of extreme ideas.
There's a lot of different ideas. Yeah, definitely. How extreme they are, I think we now see the technology move in a certain way. So many of these things could become real, but one of the things it's doing is eroding the social dimension. So like, imagine you have an agent with you all the time and it's constantly telling me, oh, remember, Thomas told you this, Thomas did this, and then telling me what I should tell you. Like now it's not you and me, it's you, me, and the agent. Or maybe you have your agent and then like we're no longer, like we are losing or giving up some of our social, like social interaction. It's being taken over.
Which is innately biological and
yes,
this is what makes us human after all.
Yes, exactly.
Social beings.
So we become less, maybe we end up becoming less empathetic, or maybe we become less social with people. Like if you took, let's say suddenly you took it away, like people just couldn't act anymore. They didn't know how to do it.
You already see that to some extent with phones and children. And even a lot of children that grew up or were born at an early stage in the COVID years, 2-3 years ago, and now they, go back to school and they have difficulty interacting with their peers and everything.
Yes, that was a big problem.
Yeah.
I have a 6-year-old and he grew up during COVID, and the social aspect was one of the hardest things. Just when COVID was when he was 2 years old or something. It was really tough. It's kind of a combination of market pressures, because you need this virtual agent. You probably have your own and you will need it at work, and everyone will start using it, so you can't not use it.
Yeah.
And then just the social erosion will happen too, and I don't know what the solution is.
Yeah.
And I think it is kind of it's something we should think about, and maybe someone should try to solve that problem. There is also an opportunity to do something better.
I think it's good to think about, we still have ownership over what we build and the tools we use and how we use them. And so it's not, I think it's not reasonable to think about technological determinism and thinking that whatever already exists, AI exists. Okay, but I'll just let things happen and not actually have control over what decisions I end up making. The future, I think we build is what we want it to be. So we should think about how this will fit, with market pressures and the social aspect as well. And, I'm sure we can find like a solution that satisfies both to some extent.
I hope so. You may also just find a group of people who reject it. Like
I think so as well.
Like Amish people who reject new technology, or you have people who just never go on Facebook. They just said, I'm not going to be on Facebook ever. If you want to reach me, you can send me an email or
create subpools of.
Yeah, I think you'll find a group of people who just reject it. But then those people will probably be in that sub-community of other people who reject it. And then there's the other mainstream that maybe adopt technology. But yeah, I don't know exactly what will happen. But yeah, you're right. We are in control. It's not, we don't have to give up and submit to technological determinism.
Yeah. Well, this was not at all planned in the...
It's
very interesting. But coming back to you, just to kind of round things off, what are your next steps with Korbit personally as well? What are you looking forward to in the next few months and a few years?
Yeah, I mean, we're working hard to build the product, make it better, get more customers, become a leader in the space. We're fundraising, we're hiring people. We have 2 new roles that are open.
What are the roles?
One is an applied ML scientist, and the other one is an ML ops engineer. Does DevOps for machine learning.
Maybe someone listening could listen to that.
Yes, I'll post it on LinkedIn.
That's good.
And so we're doing that. I think, and personally, like, I spend time with my family and my kid, and I want to try to have technology benefit the next generation. People who are children now, what world do they grow up in? What can we do to make it a better world for them? So looking at things like that and trying to help with other projects on the side.
That's wonderful. And as a last note, I like to give the guests as well a bit of an open floor and something to say to the audience, whether it be, on our topic of technological determinism or anything really that you want them to kind of take away. The floor is open.
Yeah, I mean, we're living in both a very scary time, but also a very exciting time. And I think like everyone has an opportunity to do something that was never possible before. So I would encourage everyone to try to play with the technology and be optimistic and try to build the world you want to see instead of just letting it play out, or just being a consumer of the technology. Try to build it yourself. If you don't like a certain way of doing things, or you disagree with that, go and change it. Don't just complain and wait for things to happen. Go build it yourself. You can do many more things, and you don't have to wait. If you're a student, it doesn't matter. You don't have to wait until you're done studying. You can just go build it now. So I think now is a unique time in human history to do that. Like, never had a single person had so much power at their fingertips. Something. Like, you literally have more power in your laptop now than the spaceships that flew to the moon 50 years ago. And you have more power, and you can build something now that a team of 50 engineers couldn't have built in weeks or months 20 years ago, but you can do it in minutes now. You have more power than ever, and all the more urgency to go and build the world we want.
Also, wonderful message. And thank you so much for the time,
thank you, Thomas, for having
your
me.
thoughts. And yeah, looking forward to your next steps with Korbit and yourself as well.
That's good. Thank you.
Thanks.